Alright guys, so here is a very important topic called slope. So what slope is, or we call it rate of change. Rate is just how quickly something happens, and change is when something changes, right? So slope is really a comparison of two changing quantities. So that's what we mean. So normally we let one quantity, x stands for one quantity, y stands for the other, and the relationship between how y changes when x changes, or when the second quantity changes when the first one changes, gives us our slope, or our rate of change. So take a moment and write down the various representations. So we can call it the change in y over the change in x, or the vertical change over the horizontal change. If we have coordinates, we use y2 minus y1 equals x over x2 minus x1. Simple alliterative phrase is rise over run. So here's just a quick example of what I mean by two changing quantities. Let's say that you and I are standing 30 feet apart, and then you start jogging away from me. Alright? So we'll compare the change in time in seconds to the change in distance in feet. Alright, since they're quantities, we want to tell us, we want to use units as well. So we have, and this is just a quick example to try and convey more than just the numbers behind slope. So let's say at time equals 0, you are 30 feet away from me. Alright, you jog a little bit, and 2 seconds later, you're 10 feet away. Jog a little more, 2 seconds later, you're another 10 feet away. Right? So you went in 2 seconds, that was our change in time. There was a 10-foot change in distance. So if we look at the rise over run, or the vertical change over horizontal change, and relate it to the quantities here that we're discussing, for a 4-second change in time, there was a 20-foot, right, 30, 40, 50, 20-foot change in distance. So our slope, in this case, usually denoted by the variable m, would be 20 feet in 4 seconds, right? Because you guys moved 20 feet away from me in 4 seconds. That's your rate of change. If we simplified that, 20 over 4 is 5 feet over seconds, so feet per second. So you were moving at a rate of 5 feet per second, right? 1 second, 5 feet. 2 seconds, another 5 feet, so that's 10 total. Another 5, another second, another 5, another second, another 5. So 4 seconds, 20 feet. That's what rate of change really means in the context of something. So for the rest of the slide show, we're just going to talk about crunching the numbers. So basically, if we were to look at the slope, if there's no change in y over some change in x, any number, right, 0 up but over something, that equals 0, so your slope is 0. This one is an undefined slope, because this would equate to a slope of, or a rate of change of something in the y, but the x doesn't change at all, so there's 0 change in the x. So when you have a number divided by 0, that is undefined. Alright, so we also call that no slope. And then if you have an uphill trending line, that's a positive slope. Alright, so that would be positive slope. Downhill trending, as you read left to right, this goes downhill, that would be negative slope. Alright, so reading these, the easiest way to look at these ones when you're thinking of slope is rise over run. Alright, and this little triangle, you may have seen it in science class, means change in. So this is change in something. So change in y over the change in x. So what do I mean? I mean, here, if we start at this point, we change down 1 in our y, and plus 4 in our x. So that is a slope of down 1 over 4. So that would be our slope for that problem. Here we change a plus 6 on our x and a plus 4 on our y. So the slope would be, if that's change in y over change in x, change in y is a positive 4, change in x is a positive 6, and that reduces to 2/3. This would be a 0 change in y over some change in x. So a 0 change in y over some change in x, it's the number symbol, would just equal 0. Right? Or if you remember from the slide we just looked at. And then here, this doesn't give us any points to specifically look at. So what we have to do is pick good points. So by good points, I mean ones that cross the where the grid lines intersect. So like here's a good point, there's a good point, there's a good one, there's a good one. So we can see exactly what the numbers are. So this would be a plus 3 change in y and a plus 1 change in x. So our slope is 3, the y over the x. 3 over 1, which is just 3. Alright, so then you have, there's a few more slides after this, but there's your U-try that pertains to that example, so looking at a graph and getting the slope. So now what if they just give us the points? Alright, so copy this down if you don't already have it. And slope is rise over run, vertical change over horizontal change, which gives us this formula, which you've probably seen before. Now, these little ones don't actually do anything mathematical. That just tells us that it's point number 1. Alright, so that would be like x1 and y1. So it's the x coordinate from the first point, if this is our point number 1. This would be our point number 2. So y2 and x2 would be this one, y2 and x2. So now we can plug it into our formula. Slope equals y2 minus y1 over x2 minus x1. And that gives us y2 is 5, y1 is 0, so minus 0. x2 is 1, x1 is negative 8, so minus negative 8. So that's 5 over 1 minus minus 8 is like a plus 8. So that gives us 5/9 is our slope between those 2 points. And if you were to graph them on a graph paper, you'd get the same thing. So here we have x1, y1, x2, y2. So that gives us 3 minus 3 over negative 4 minus 8. It's very important that you subtract these in the right order or you'll get the opposite slope. So that would be 0 over negative 12, which 0 divided by anything is 0, so that's our slope. Here we have 7 minus negative 1 and 4 minus 4. Oh, 4, yeah, minus 4, that's right. Minus a minus is plus there, so we have 8 over 0. Anything divided by 0 is undefined, so this would be a vertical line. 0 slope would be a horizontal line. So 4, now this is our y minus y, y2 minus y1 over x2 minus x1. So we have 4 minus negative 2 and 3 minus 9, which gives us minus a minus would be a plus, 6 over negative 6, and that reduces to negative 1. Alright, now you have a U-try that is very similar to that. Don't stop though, because we got a little more. So here's your U-try. Make sure you copy this down. Alright, fill these in because I want you to actually write those out. Now, sometimes you may be given the slope and a point, but be missing one of the coordinates. So here's how you solve those. You just set up your slope formula. Slope equals y2 minus y1 over x2 minus x1. This is a good general math thing to do. Anytime you're trying to solve for one variable, write the whole formula out and plug in all the numbers. So here's x1, y1, x2, y2, so we're really missing this one. So plug in all the other numbers. Slope is 1 equals -2 minus 8 over r minus 6. So simplify that top, and we get -2 minus 8 is a -10. And now you cross multiply and solve. So that's like 1 times 1 is the same as 1 over 1. Multiply, cross multiply and solve, we get -10 equals 1 times this is r minus 6. Add 6, and we get -4 equals r. So again, for this one, plug in the formula and then just leave out the one thing you're missing. So this is our y2 coordinate. So we have r minus -3 over 7 minus -1. Alright, now a minus a negative is going to be a plus, and minus a negative is going to be a plus. So we have 3/4 equals r plus 3 over 7 plus 1 is 8. Cross multiply and solve. So we have 3 times 8 is 24 equals 4 times r plus 3 is 4. Remember to use the parentheses, r plus 3 from our last unit, and now solve. The easier trick here is just to divide both sides by 4, and we get 6 equals, because that cancels, 24 over 4 is 6, equals r plus 3 minus 3, and we get r, my bad, we get 3 equals r. Alright, so you have one problem like that to try as well. Alright, so several you tries tonight. Go back, rewatch, pause it, rewind, whatever you got to do to get the topic. If you have any questions, go ahead and write them down on the margin or the corner so you remember to ask them next class, and we'll see you then.